Hello! In this video we are going to put the focus on the notion of requirement. What is a requirement and what kind of attributes and types it has? Let's start with its definition. For industrial domains, a requirement is a condition or capability that must be met or possessed by whatever human invention, and it must be based on a clear need. As you can perceive, the definition puts the focus on several interesting characteristics. A requirement defines how a system must be or must operate. The requirement must exist because of a reason, and this reason is owned by a human or other system. Let us try to connect the definition with examples. I am sure that when you were a kid, you learned to ride a bicycle, isn't it? When a factory decides to create a new bicycle, it is necessary to define requirements to clearly determine what must be designed and produced. So, hands-on work. Can you think of one requirement that a bicycle must have? Try to do this effort. And even better, stop this video and write it on a paper or in a computer. It is not easy, right? What should I write? How to write it? Do I have to write or draw? So many questions. Let me write some examples for you using English language. The bicyclist shall be able to transport herself pedaling with the feet. The bicyclist shall remain clean when the road is wet. The traffic control police shall be able to visualize the rider from 20 meters or 65 feet. You can see that these requirements describe what we want but are not specifying anything about the bicycle. These kind of requirements are called stakeholder requirements, and they represent the point of view in form of needs of the related agents around the system to be built. Important. Stakeholder requirements are not requirements that are written by stakeholders. They are requirements about the stakeholders and what they need the system to fulfill. The stakeholder requirements will be the source to produce requirements about the real system. In our case, the bicycle. Every stakeholder requirement must be satisfied by one or many system requirements. Stakeholder requirements are derived into system requirements. For example, from the bicyclist shall be able to transport herself pedaling with the feet, we should conclude that the bicycle shall include a crank roof with 2 pedals. This last requirement is a system requirement, a requirement concerning the system. Can you see the difference? Instead, this kind of 2-dimensional distribution, a first one from needs to requirements and a different one from generic to specific topic, is the cornerstone of requirements elicitation. The needs originate requirements through analysis, and both needs and requirements evolve from a generic view to a specific view. In the case of complex systems, the generic view is describing the system at high level of abstraction, system thinking, and complexity is solved by specializing the view from the whole to the parts, subsystems and components. For example, from the need to transport a person using own resources, we got the stakeholder requirement we said before, and the needs and requirements are specialized in a decomposition exercise where the component requirements are elicited. You can see how the component requirement is connected with the system requirement, which is connected with the stakeholder requirement. And the real good thing, the component requirement is originated by a clear need. Okay, we know what is a requirement, but how should we represent it? There are 3 different ways to represent requirements. Informal methods, using textual language supported by diagrams. It has few or no mathematical support. Formal methods, based on rigorous mathematical notation that ensures the requirement correctness. Or semi-formal methods, combines formal and informal methods, like UML, SysML, Darts, etc. At the time we produce this video, the experts are involved in a very exciting debate. Which way is best to represent requirements? We will not get into this debate in the video. I will simply say that the most used way to write and represent requirements today is using textual requirements. So how should you write a good textual requirement? Basically, you must do a simple thing. Write coherent information in a coherent way. The ISO 29148 standard defines a basic structure for a functional requirement, which I like very much, and I think it can be used generally. A good requirement should have the following structure: a condition affecting the requirement, which is optional, a subject for the requirement, the shall term, an action representing the dynamics or operation, an object for the action, and a constraint in case of necessary. Nice, isn't it? What must the attributes of the requirement be? Every requirement must have a unique identifier, as well as its text statement. In many cases, the requirement needs also a rationale to explain its necessity, as well as a traceability information between it and other work products, like requirements, other, test cases, designs, etc. Information about exchanges is also necessary, in the form, for example, of version. The originator and the requirement type are also relevant information. We are almost done for today. I have just mentioned that the typology of the requirement is something that should be controlled. Indeed, I was implicitly telling you that there are many different types of requirements. More precisely, we must produce requirements affecting many different views of the system. For example, we can define requirements for describing capabilities that a system must have, or the way it must be maintained, or even requirements for defining the color of a particular part. The definition of the different requirement types is not mature yet in the literature, and in most cases, every organization defines its own types. However, some of them are clearly known. I will put an example of every type together with it in the screen. Stakeholder requirements, as we have described them before. Functional requirements, describing capabilities, functions, or tasks that a system must have. Performance requirements, describing how well or in which condition the system must perform a function. Interface requirements, describing how the system must interact with external systems. Operational requirements, the interface requirements between the system and the humans. System property requirements. They are usually called not functional requirements or ELITIS requirements because they state not functional properties about the system. For example, quality, security, maintainability, reusability, portability, etc., etc. Okay, let's summarize. In this video, we have studied in more detail what is a requirement, and you know now the attributes, the types, and the way to represent them. You are capable now to write your own set of requirements. Why don't you try writing the requirements for the exercise related with this video? Have a very nice day. Bye.